Hey, this is Horner, and this is worksheet number 3 for electricity, the solutions for number 6 and number 7. So we have a series circuit. Here's our series circuit at right, and it says correctly place the ammeters and voltmeters to measure the potential difference and the current for the entire circuit as well as for each one of the resistors. So the first thing that we're going to do is we're going to remember that in series, the current is the same. So current is the same, and the voltage adds. So I would write down that first. Now that we know that, let's go ahead and put in where our voltmeters will go. So remember, voltmeters always go parallel to the circuit part that you want to measure. So there's the first one. Here is the next one. So we're going to put a V here, and it's in parallel. And then we want to measure it for the whole circuit. So we're going to do that from A over to B. And we'll actually say that this is for the battery. And I think that's really important. Ammeters. We're going to put an ammeter right here. That ammeter will measure the entire circuit. Then remember, you always put after resistor. We're going to put an ammeter. So we'll put it here. And then we'll put another ammeter on this side after this resistor. So if there's flow going through, this is like measuring the flow of water after it goes through the first shower head, and then the flow of water after it goes through the second shower head. They want us to find the change in potential between A and B. So between A and B, they've already told you what that is. That is 3 volts. And because it's across the battery, we're going to call that positive 3 volts. For B to C, we need to now figure out what is the potential drop, or what is the potential difference across this 12 ohm resistor. So before we can even do that, we need to go through and do some of our math. So we know that the resistance in series is equal to the first resistor plus the second resistor. So let's go ahead and just plug those in. So we'll do 12 plus 6. That is equal to 18 ohms. So there's our total resistance in series. Once I know the total resistance, let's find the total current. So total current, so I, and we'll put a T there, is equal to the voltage in the circuit divided by the total resistance in series. The voltage is 3, so we know that, and we just calculated that we have 18 ohms. So this will go on the bottom. And so our current in the entire circuit is 0.167 amps. And because we said current is the same, we know that we have 0.167 amps going through this resistor, and we have 0.167 amps going through this resistor. Remember, this is because of the junction rule. So the junction rule. And remember, the junction rule just says that whatever the current is going into a junction has to be the same as what comes out. So when we go into B, it's 0.167. We come out. When we get to the resistor, it goes into the resistor, 0.167, comes out 0.167, goes into this resistor. You kind of get the clue there. If that's true, now we know the current in each one. Let's figure out what is, from B to C, the measurement in the voltmeter here. So to do that, we know that V is equal to I times R. Our I here is 0.167, and the resistance is 12 ohms. So we see that right here. 12 times 0.167 is going to give us negative 2 volts. For C to D, we're going to do the same thing. So voltage is equal to current times resistance, and that is equal to 0.167, but this time only times 6, and so that gives us negative 1 volt. And then from D to A, I don't have anything. Why do I not have anything? Because I've used all of the potential difference up, and you'll see that. So remember that your change in V for a loop, so we said the loop rule says that all of the potential in the circuit should add up to 0. So across the battery, we have positive 3, we lose 2 here, and then we lose 1 here, which means we now have 0. So that's good. The current in the circuit, we already did that. So the work for the current in the circuit is right here. And so we can just draw an arrow there. And then they want to know what is the power dissipated by each resistor. So let's do this first for the 12 ohm resistor. So we're going to put R12, and the equation for power is equal to the current in that resistor times the voltage across that resistor. So here the power is equal to 0.167 times our voltage in the first one, which is 2. Now we're going to use the voltage across it, and we're going to use absolute value. We don't want to use the negative value. So this will be 0.333 watts. And then for the R6 ohm resistor, that's also P is equal to IV, but for our 6 ohm resistor, and that's 0.167, because remember that doesn't change, times 1, and that is 0.167 watts. So now we've done everything that they've asked, including the part that I added, and that is to talk about where to put the volt and the ammeters. So you've got to make sure that you can do that correctly on the AP test. Let's go ahead and take a look at number 7. Number 7 is now a parallel circuit. So we did a series circuit first. So this one is definitely parallel. So one thing you might want to write down is that it is parallel. And in parallel, remember, the voltage is the thing that is the same. So the voltage is the same. And this time the current isn't the same. The current adds. So you want to make sure that we're getting these correct. Remember, we said the way to remember this is I want to take a private vacation in South Carolina, and if that's true, in parallel the voltage is the same, and in series the current is the same. So that's just a little way to remember what those mean. So they first want us to find the resistance of the circuit, and you'll see sometimes they'll say equivalent resistance, and that's just the same thing as the resistance in parallel or the resistance in series. So they'll say REQ. I like to use RP and RS because then that specifies where it came from. So either of those would be fine for this one. Let's go ahead and use our equation. 1 over REQ is equal to 1 over the first resistor plus 1 over the second resistor, which is equal to 1 over 12 plus 1 over 6. I know you could use just finding the common denominator. If you want to do that, that's fine. You should come out with the right answer. So if I do this and I use a fraction, I should get, well, 12 divided by 3. And so that is, not 12 divided by 3, but 3 divided by 12. So here I've got 3 over 12, which is 0.25. So 0.25, but that's 1 over REQ. So I have to flip it. So let's flip it now. So the equivalent resistance, or the resistance in parallel, is equal to 4 ohms. So there is our there's our answer for the equivalent resistance of the circuit. They want to know what is the change in potential between A and B and between C and D. So we know, due to the loop rule, so we know that the loop rule, and this is important, the loop rule says that the change in potential around the circuit for each loop should equal 0. And because we have positive 3 here, and we make our first loop, so let's do this loop in yellow. So here is our first loop. That loop would have to also equal the negative value of the battery. So this is going to be negative 3 volts. And then we have another loop here, and so we'll make this one green. And this loop goes here, over, back, up, and then over again. Notice it didn't go through AB, but it did go through CD. So when we look at C and D, this one is also negative 3 volts. And if they want you to explain it, you say it's due to the loop rule, which means that the change in potential all the way through from the beginning of the battery over, down, through, and back should equal 0. The next thing that they want us to find is what is the current in the wire leading from the battery to point A. So I want to go from the battery over to point A. So to do that, I've got to figure out what is the total current. So here I want the total current. So that's current total is equal to the voltage divided by the resistance in that first resistor. So that is for the first one. That's not for total. So really what we need to do here is I need to erase the 12 there. And that is the total resistance. Sorry, my fault. So that's the resistance in parallel. This is going to be 3 divided by, and remember our resistance in parallel is 4. So that's going to be equal to 0.75 amps. Let's do the same thing for the 12 ohm resistor. And so that will be equal to the voltage divided by the current, by the resistance and the 12 ohm resistor. And that's equal to 3 over 12, and that would be equal to 0.25 amps. And finally, we need to do the same thing. This time we're going to do it for the last one, which is the 6 ohm resistor. And that is equal to 3 over 6. And so that will give us 0.5 amps of current. The last thing they want us to do is determine how much power there is in each one. So remember, P is equal to IV. So this is equal to 0.25 amps times 3 volts. Because we know, and this is the power in the 12, the current was 0.25. We have that here. And the 3 volts is what is the voltage in each one of the resistors. And so our power here is 0.75 watts. And then the power in the 6 ohm resistor is also equal to IV. So that is 0.5 amps times, and then we have 3 volts again, because the voltage is the same, and for both resistors because they're in parallel, and this is going to end up being 1.5 watts. The only thing we didn't do is put in where we need our meters. So if I want to measure the total current, I can put it here. If I want to measure the current going through the 12 ohm, I like to put it here. You can put it on either side, but I always like to put it quote-unquote after. And then I'm going to put another current meter here. So these will not read the same thing. All 3 of these should be different. If they're not, then we could go back and we could try to figure out why, because we've made a mistake somewhere. We need to measure the potential difference or the voltage. So we're going to do one right here. Oops, let's undo that guy. So we're going to go back and let's go ahead and put this in. So there's a voltmeter right there. And then we need a voltmeter here to figure out what is the voltage across that resistor, and then, or the potential difference. And then we need one more voltmeter here, and that would measure the potential difference across the 6 ohm resistor. And that is the end of these 2 problems.